Now, does this converge? Who says it converges? Who says it does not converge? Who says it diverges? Who doesn't know? This is a hard series. This is one of the hardest series there is. The worst series in the world is this one here. This is the worst series in the world. Hands down the worst. But it does illustrate the point. The terms are going to zero. Most certainly. Who does not see that the sequence is going to zero? 111th, 112th, 113th, 114th, 115th. Huh? The terms are going to zero, but you are adding infinitely many. The question becomes, are the terms going to zero fast enough? And that, folks, is the basic conundrum we are stuffed with for the next 4 weeks. The terms are going to zero, but you are adding infinitely many, so are they going to zero fast enough? Now, you know what I'm talking about. So here is a series, 2 plus that, plus 1, plus a half, plus a quarter, plus an eighth, plus a 16th, plus 1 over. Does this series converge or diverge? It converges. Most certainly the terms are going to zero. 1 over 64, 1 over 128, 1 over 256, 1 over 512. And if we say that this is convergent, it's actually 4. It means that the terms are going to zero pretty fast. Anybody know how fast they are going to zero? Exponentially fast. What is the exponential function? 1/2 to the power x. Very fast. That is to say, in all of this business, the first thing you want to ask yourself about your sequence is, are the terms going to zero? Ms. Yasmina, if the terms are not going to zero, what will you conclude? That you will not add them all up infinitely. If the terms are not going to zero, don't even bother trying to add them all up, because it's going to be infinite. That is called the divergence test. You have a sequence AI, and AI does not converge to zero as I goes to infinity. These terms are not going to zero. We may conclude what? This series diverges. In other words, it is necessary for the series to converge that the terms of the sequence go to zero. Because if the terms of the sequence don't go to zero, the series does not have a prayer of converging. I'm sorry about the logic here, but it's going to be an encyclopedia of logic. When it comes to this business, I would say the first thing you ask yourself, are the terms going to zero? And if they are not, you cannot add them all. And if they are, you say, what, Mr. Tyler? Dang! Are they going to zero fast enough? That means more work for me. The terms are going to zero. That's a hard problem. Are they going to zero fast enough? That is your problem. So the first thing you ask yourself is, are the terms going to zero? No. Yippee! No more work for me. Take your problem, go away. And if the terms are going to zero, you say, oh, did you have to make it hard? Now I have to know if they're going to zero fast enough. And that is where our analysis is going to go. That is to say, this is the sin qua non-convergence. Who's got Latin? Without which there is not. Without this, there is no convergence. With it, you can conclude nothing. Okay? If the terms are going to zero, you may conclude nothing. You say, dang, more work. Let me give you an example. So here's a sequence. Does this series converge? Now, let me show you Dr. J's favorite trick. Put your pen down. We are adding the terms of a sequence. That is to say, that is a series. But it is adding the terms of a sequence. If you have no idea what I'm talking about, then add the first few. What is the first term? Yes, ma'am? Five sevens? What is the one after that? 7? 10. And the one after that? Come on. 1, 2, 3, 4, 5. 5 times 2 is 10 plus 3 is 13. 5 times 3 is 15 plus 4 is 19. Come on. And the next one, the one after that, 6. 6 times 2 is 12, 15. 6 times 2 is 18 plus 4 is 22. I want to know, can I add them all up? Now, assure yourself that this is neither geometric nor arithmetic. Who says this series converges? Raise your hand. Who says it diverges? Raise your hand. Who doesn't know? Raise your hand. Who says it diverges? I say it diverges because I say the terms go to 2/3. The terms are going to what? 2/3. And if you add 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3, you're going to get infinity. So the terms do not go to 0. Everyone with me? What is AI? 2I plus 3 over 3I plus 4, which is a rational function degree, or you can do L'Hopital's rule, blah, 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 blah. As I goes to infinity, AI goes to what?
To 2/3.
And 2/3 is equal to 0 or not? Last time I heard it's not. Which is to say that this says what? This series diverges by the divergent test. Get your logic correct, Mr. Harris. I'm telling you, you're going to be blasted with logic. Again, Mr. Harris, I'm adding the terms of a sequence. And the terms of this sequence approach what value as I goes to infinity?
2/3.
Is that equal to 0?
No.
That means the terms of the sequence do not go to 0, which means that the series cannot converge. That's what it says. Then diverges. Are you with me, Mr. Harris?
Yes.
If you want to add a sequence, infinitely many terms, and you are praying that you'll get a finite number, the first thing you better pray for is that the terms go to 0. Because if the terms don't go to 0, you don't have a prayer. These terms are going to 2/3. Which is to say you are just going to be adding 2/3 plus 2/3 plus 2/3 eventually. Or numbers very close to 2/3. And a number very close to 2/3 is very far from 0.